Charges Q1 and Q2 lie inside the and outside the outside respectively of a closed surfaces. Let E be the field at any point on the S, and phi be the flux of E over S. Okay, we have to see the various parts. Okay, we have to see the various parts. Okay, now there are two charges Q1 and Q2. Q1 is placed inside and Q2 is placed outside the sphere. Okay, Q1 is placed inside and Q2 is placed outside the sphere. So let us check the following statements. If Q1 changes, both E and phi changes, correct. Okay, because the electric field intensity on this part, on this surface S, will be equal to the electric field intensity on this surface S will be directly proportional to the flux. Okay, and the flux is directly proportional to the charges inside the sphere. Okay, so Q1, if Q1 changes, the flux will change and simultaneously the electric field intensity will change. So option number A is correct. Let us check the option number B. If Q2 changes, E will change but phi will not change. Okay, now the flux depends on the total charges enclosed in that sphere divided by total charges enclosed in the sphere divided by epsilon naught. Okay, now if Q1 is not changing, only Q2 is changing, the flux will remain same. But what about the electric field intensity? If I say the electric field intensity of, let us say, along this point, okay, so if I say the electric field intensity due to the Q1, it will be in this direction E1, and due to the Q2 it will be in this direction. Okay, and if it is negative charge, there will be electric field intensity and so on. Okay, so basically electric field intensity E1 is in this direction and E2 is in this direction. So if E2 changes, the total net electric field intensity will change. Okay, but the flux will remain same. So option number B is also correct. Okay, if I consider option number C, if Q1 is equal to 0 and Q2 is equal to 0, okay, that is the external and internal is equal to 0, then E is not equal to 0 but phi is equal to 0. Okay, so if so the phi only purely depends on Q1. Okay, phi over here we have seen that it purely depends on Q1. So if Q1 is equal to 0, phi will be equal to 0, but the electric field intensity will not be equal to 0, because even if the Q1 is eliminated, there is the electric field intensity developed due to Q2. So option number C is also correct. Now if I see the option number D, if Q1 is not 0, then phi is equal to not 0, okay, which is true. Okay, first option is true. But if Q2 is equal to 0, is equal to 0, not, it is not necessary. If I consider that Q1 is a non-zero quantity and Q2 is 0, so I will not draw that part. So there is still electric field intensity developed due to Q1. Okay, so option number D is incorrect. So the correct answers are option number A, B and C.